thank you everybody for finding your way through the convoluted corridors up to here. Plus, it's the last day of the conference, so we're super happy that you guys are here. I'm Frederic from Laval University in Canada, and Catherine, who's also from Laval University in Canada, and I have a background in ecology, and she's a computer scientist, and we collaborated on leveraging EarthRanger in the Arctic. So the goal today is kind of to showcase a bit what our system looked like. It's quite different from the African system that we've seen throughout other presentations of the conference. And what was the first year of deployment? What were the challenges that are specific to our study site? And yeah, show pictures of what the Arctic looked like. So to start, we need to fly from Cape Town and go all the way up north to Canada, north of Baffin Island. It's actually quite far north. There's not that many people living in these areas, but there are native people, Inuit, that live in villages like this one, which is Pond Inlet. It's a coastal community just nearby where we work. In this environment, it's basically winter almost all year long. So from September to May, it's covered in ice and snow. And then there's 3 months during the summer where snow melts and there's a lot of birds that come there. And it's the time where we can study most of the wildlife that goes there. So the native communities that live there are also very connected to the land. Most of the food protein of these communities come from wild game. So they hunt caribou, they hunt seal, they hunt belugas. And so there's generally no conservation issue with these hunting practices. They're in very low density, and it's remain a major food source for these communities. Here we can see this is a little cabin that they haul behind snowmobile, and when they go hunting on the land, they'll sleep in this cabin. And it's during the summer, it's 24-hour daylight. So this is at 1 a.m. In the morning. So the sun is up, kids are playing hockey. It kind of shifts the schedule of everybody. It gives a lot of energy to just be there during that time. But then the drawback is that during winter, it's 24-hour night, which can be hard. And so the national park where we work is Circumpolar National Park, also called Bylot Island. It's this green area. The village Pond Inlet is down there. And so it's a park that was founded in 1999, and it's a major refuge for a migratory bird that will go nest there. So there's about 30 species of bird that nest there, and it also hosts Arctic foxes, lemmings, and that's about it. So it's quite a simple ecosystem, but quite rich for the Arctic. And the research program we work with started because of these guys. So the greater snow geese that are migratory birds, they winter along the eastern coast of the US, and then they migrate all the way up north to breed in the summer. And the thing with the greater snow geese is that in the 1970s, there were about 20 to 30,000 individuals. But then with industrialization of agricultural practices, it provided an infinite food source for greater snow geese, which started feeding in cropland. And so they had unlimited food resources, and this allowed them to grow exponentially. So in these years, it went from about 30,000 individuals to nearly 800,000. It's really, really a massive population. And the thing is, when you go to the Arctic, you arrive there, and then there's no cropland anymore. So they need to find food, and they'll just browse everything. And the picture down here is some massive damage that we're seeing in Arctic ecosystem of the Western Canada. There, it's even worse. They're at 12 million geese. So it's like really, really abundant, and there is desertification of these systems because of the browsing. And so we'll see how that problem unfold and how we found a way to control this issue. But first, I wanted to show a bit what the fieldwork looks like and basically what are the constraints that we have when we work up there. So when we arrive by plane in Pond Inlet, and then we leave by snowmobile on the ice, and we get to our main camp. So we'll have these snowmobile with the the trailers in the back that brings our gear. And we get to our first camp that looks a bit like a spaceship. It's super remote and disconnected, so we have solar panels for electricity. There's no cell phone, there's no internet services, and so there's nobody living there apart from us during the summer. And we get our food with planes that come in the early season. They land on the ice with skis. We offload all the food, and then we store that for the entire 2 or 3 months that we'll stay in this area. So there's a team that goes in early May. They set up that camp, open the camp, and then leave with snowmobile and cross the island from the top. You can see the little map here. So they cross the island from the top of the island to go down by snowmobile in the mountains. And they get to a secondary camp that we set up where we have these prospector tent. It's a bit more rustic. And we have antennas for VHF communication, and then our tents. For water, we melt the snow, and then when the snow eventually goes away, when the sun comes more during the summer, then we can access water in rivers. And so sometimes it's quite harsh because of the snowstorms that we have, but we always find ways to kind of be cozy in these tents, so it's not so bad either. We have quite a bit of support. And then from there, we'll leave into small temporary camp. So all across the island, we'll have these temporary camp where we'll stay 2 by 2. So we're teams of 2. We each have one personal room and then a kitchen tent where we cook. And we'll move like this every maybe 7 to 10 days to survey the entire island. So we go like that, and eventually all is not so grim. The snow eventually melts, the lake become open, and that's the time where bird finally come in the system. So the greater snow geese, their colony is down there, the yellow patch down to the left, and there's about 50,000 couple that come and nest on this island. So when the program started, we started monitoring nesting success and survival of the goose to try to find what was happening with this demographic explosion. And then we realized that because the food was so abundant, they were reproducing massively, and they were able to increase their population abundance exponentially. And the solution might surprise a bit because it's quite a different context from what I've been seeing during the past days. But the solution was actually to encourage hunting. So in this case, there's native communities that are hunting snow geese, and as well as southerners that would hunt. And by promoting hunting and liberalizing the hunting regulation, actually it allowed to stabilize the snow goose population and protect Arctic ecosystem. But then, even after stabilizing the snow goose population, there were variation in nesting success that we were seeing. So there's years where nesting success is much lower than others, and these variations drive the population dynamic of the population. And so we were interested in knowing what was happening. And we soon realized that it was not enough to focus on the snow geese. We had to consider larger than only the snow goose nesting success. So they don't exist in silo. They have a predator, mainly the Arctic fox, and then started a project working on Arctic fox, where we surveyed across the island to find dens and monitor the dens. So the fox are white in the early season, but then quickly molt and become brown like that. So we mapped the different dens across the study area, and we monitored them with automatic camera as well as radio collars on the foxes to have a better understanding of what was happening. But then, even though we were studying the foxes, we still have an incomplete picture because the fox eat lemmings, which are another prey that are really abundant in the system. And so we needed to start understanding what was happening with the lemmings. So there's 2 species of lemming, colored lemming and brown lemmings, that we trap with these Longworth trap. It's live capture, mark recapture surveys to have estimates of densities. And so the lemming abundance was fluctuating quite a lot, And every 3 to 4 years, there's cycles of abundance where there's peak lemming density, and then it collapses, and then peak lemming density, and then collapse. And actually, during peak lemming density, when there's abundant food resource, it protects the geese. So the geese benefit from the lemming being very abundant. So that's an indirect interaction between the lemming and the greater snow goose through their common predator, which is the fox. And so progressively, as year passed, we started added players in this equation. So there was the ermine, the snowy owls, that are predators of lemming that are important for their population dynamics, and then some avian predators, as well as all of the 30 bird species that nest in the tundra. So we surveyed each of these species, and now we have a very long temporal trend on that. And it's interesting because it quite shifted from a more oriented on the snow goose conservation problem towards an entire ecosystem that is monitored, and that gives us a witness of what would happen with change that are happening in the environmental conditions. So now it's one of the rare systems in the Arctic where we have actually the entire community understood. We have people working on snow as well, and geomorphological surveys. So we have very different component of the system, and we can see how the entire system can reorganize or not depending on how the environmental conditions change. But that comes with a challenge, is that, so as I showcased, it's quite remote, it's quite hard to go everywhere, and we have a very short season. So we're about 20 people on the entire island, and say our team work on all the nesting birds everywhere, and so we're 5 maybe in the field, and we need to go everywhere to survey these birds. And what we used to do was, and those are the indirect interactions. What we used to do was to do line transect surveys like this. So those are, each line is a little 500-meter survey where an observer would walk and record all the bird species that they would see. And this part of sampling represent massive effort. So we'll have a team of 5 working during 3 months doing just that. And in the end, we can have a good understanding of what was happening, but we're missing large parts of the area. And in these other parts, there are people working on lemmings, on foxes, on snow geese, on snow, but that are not surveying the birds. And so in the field, not last year, but the year before, I was doing surveys and thinking, like, is there something we could do to improve that? And maybe there would be an app that we could use to monitor our sampling effort, but that we could give to everybody and say, hey, can you record observations? So I tried different things that were really bad, and I was a bit like, meh, I'm not sure that it's really gonna pick up. But then I was talking with Catherine, and we were collaborating on another project and stuff, and I was talking about that, and then she said, well, I got the solution. And so I'll let her talk.
So ER Mobile was quite a natural solution for us because since we don't have any internet connection for 3 months, the offline capabilities of ER Mobile were critical for us. So that was a really nice and necessary feature. And also, we really like the fact that the interface was really simple and quite easy to go through, because all of our colleagues are really, really busy in the field collecting their own data for their PhD project or their master's thesis. We have a short amount of time to collect all of this data, so asking them to add another task to their already quite big workload required us to have a simple interface to show them, because if it was quite complicated to use, none of them will have adopted ER Mobile in the field. And also, since we're a scientific project aiming at understanding the ecosystem and producing knowledge out of it, data preservation and centralization was really critical for us, and the fact that everything was stored in a cloud database was a really nice feature of ER Mobile as well, so we didn't have to care about how the data was stored at all. And also, since we are a dynamic project with evolving questions all the time, and the Arctic is always evolving, the fact that it is really customizable and that it is really easy to create reports and customizable event types was a nice feature as well. So we had really the impression that Mobile was the best choice for us to try this field season. So this year we deployed EarthRanger in the field for the very first time. We didn't aim to replace all of our, I would say, manual field recordings right now. We see it more as an iterative process. So this year was really the first test where we were aiming at identifying potential problems that might arise in the field and troubleshoot them afterwards, which is why we are here to present you how it has been. But here's the interface of the EarthRanger web app, where you can see that quite a lot of observations were recorded in the field, actually. You can also see that all of the observations are clustered in very specific areas. That's because people in the field are moving in a helicopter quite often. They're staying in a camp for a few days, and then they climb in the helicopter, they go to another place, they establish themselves, they collect data, and then after a while they move, and so on until the end of the season. So our data collection works in a way where the observation are concentrated on specific areas and not widely spread. So that's what we were expecting to see, and we were really happy to see that everyone we asked to contribute to collect the data agrees and contributed to this effort. So here's how our app looks like. So the first image on the left is imagine yourself, you're opening the app and you see this beautiful landscape with snow and barren Arctic habitat. And let's say you saw a bird, then you open the report section of the app and you see all of these options that are available to you. We use the alert coloring, like the priority coloring system, just to differentiate the bird sighting reports to more specific reports that were aimed at other mammals, such as foxes, for example, or some people in our field site are also interested in plant stuff. So we had one report about plants, but mostly bird sightings, and that was our main goal to validate and troubleshoot before considering other stuff we could do with Mobile, but we included them in the reports anyway, just to see if people were recording them a lot or not. So all of our bird species report are made in the same way. So let's say you see a long-tailed duck, you would open the Mobile app and you will enter the number of individuals you saw. After that, you will enter the distance at which you observed the species, and then you will specify whether the bird was showing any kind of breeding behavior, or if you found a nest, for example, or if you didn't know how to classify the nature of the behavior of the species at that moment. For now, for this initial test, we only considered analyzing the observation itself, so we didn't care about anything related to distance and status, but we included them anyway, just because we are aiming to use them afterwards if Mobile ends up working well in the field. But for now, the number of individuals allowed us to perform our initial analysis and validate if Mobile was able to indeed be a potential solution to replace our manual field recordings in the field. So basically, we analyzed the results from this first test in two ways. The first thing we did is to analyze the quality of the mobile tracking data, because we want to use this tracking data to have an idea of what we call the sampling effort in the field. So Let's say you want to estimate the abundance of a certain species on the island. You really need to know where the field workers went to be able to estimate this abundance in an appropriate and reliable way, because otherwise you could include regions where in fact you don't know anything about it because no one went. So we really want to focus on strictly on areas where we know that people went. So mobile tracking data is really essentials for us to consider before performing any kind of analysis on the species sighting themselves. So we first checked how the tracking data looked for every of our colleagues, and we noticed that some of them had quite a bunch of pathological examples, such as this ones where we can see that the person was climbing in an helicopter and going from the top and then going back down at the south on the island and then coming up again, but it gives the impression that there's a straight line between point A and point B, which is not really what had happened. And when you plot the raw tracking data set, you get something like this, where you see like all these straight lines going from one point to another, which is due to the fact that people climb on an helicopter and go to another point in the area of the island very quickly in a short amount of time. So that kind of noise, in fact, is a bit different than the noise you would encounter with conventional GPS colored data sets. So, for example, when you install a GPS tracking device on any kind of animal, you might get no data for a certain amount of time. But here we had various sampling rates due to the fact that everyone's phones were different. We had very high distances between one point and another, even though like the time between those points wasn't really high, just because the person took an helicopter. So we had to consider a bunches of specific challenges specific to our cases that don't arise necessarily in conventional GPS colored data sets. Basically, we solved this problem just by applying a filter on the data that was really tackling all of those specific challenges, and we ended up with something like this that is really what we were aiming for. So you can see that people were staying in an area for a certain amount of time, walking, collecting data, and then moving up somewhere else, and it gives a landscape of effort like this. And this is the sampling effort that we want to consider in our further analysis of the observation. So we won't consider the places on the island where the field worker never been. So we also checked what kind of error the various phones had, because for this first test in the field, we asked all of our colleagues to bring their own personal phones. This was to test if there was one phone better than another, for example, and the way we assessed if it would be a good idea to buy specific phones for the next year or not is to first of all calculate the empirical GPS error of all of the phones. So basically, when you buy any kind of GPS device, the provider of the device will give you the theoretical error of the GPS, let's say 5 meters, for example, but oftentimes this error is not the one you observe in the field. And since we were so remote, we thought that maybe this error would be way higher than what, for example, the iPhone specs were telling. So we had to verify that. And the way we did is we knew when people were sleeping. For example, here, there's a person sleeping in a camp we call Camp 1. So those are the boxes here you saw in gray. And you can see that even though the person was staying in the box, the points are going quite far from the box, and that's because there's an error to the GPS, so it won't record at always the same point, even though the person is not moving. So we calculate the GPS error for each of the phones that our colleagues had, and we concluded that the iPhones that were the best by far compared to the others. We talked to our mobile team this conference, and some of them told us that an hypothesis would maybe be that Android phones always have their flavor of Android. So maybe like by adding their flavor, it makes the system not as reliable as iOS, for example, which is a quite controlled environment. So maybe that will be a reason why. So, but still that indicates us that moving forward, iPhones will probably be the best phones to buy for all of our field workers if you want to replace manual field data collection by technology or mobile-based field data collection. And we also checked the sampling rate. So we were interested in seeing, is there any kind of phone types that are recording data much faster than others? So we know that in the ER mobile, when people are not moving, the app stops recording or slows the recording of the data. So we we remove that data away and measures only the sampling rate for the moments where we knew that the field workers were moving, and we noticed the same constatation, the same results as for the GPSer, that the iPhone's models were more reliable in general than the Android ones, and also that the most recent phones were also much better than the older ones. So we had phones ranging from, I think, 2015, can record relocations as fast as one or more per minute, and some of them can have breaks as long as 15 minutes between them. So it's quite important to choose a phone that is reliable enough and recent enough to be able to record data quite frequently. So this data allows us to will really help us moving forward and define which kind of phones we want to invest later on for the pursuit of this implementation of EarthRanger Mobile in the Arctic. And then we finally analyzed the wildlife observation data we made. So in total, there was approximately 1,300 individual wildlife observation that were recorded between June and July 2023. So that's a really satisfying number for us. We didn't force anyone to use the app for this time, and even though we didn't force anyone, the majority of our colleagues were really enthusiastic about it and really recorded a lot of data in the field for this first test. So that was a really nice thing to notice when we first looked at the data at the end of the field season. And I can let Fred just resume what the data looks like.
Yeah, so we were really happy to look at the different bird species that we had, and then we were wondering if the people using the app would reflect the distribution of these birds. And so from preliminary visualization, we can see that, for instance, the blue dots are the snow bunting right there. That's a bird that's really associated with snowy areas, and it was reflected by the app. The common ringed plover there are always nesting close to rivers, and it's the red diamond, so it was also reflected by the app. And then you have the American golden plover that's all along the coast. And we expected for the American golden plover to see less plovers within the goose colony, because there's a lot of foxes that eat the nest of the plovers when they nest there. Then we had some species that nest in wetland, and again we don't see the wetland on this image, but the clusters are located where the wetlands are, which we were happy about. And then some predators of goose eggs that are mostly located within the goose colony. So those were things we expected, but it's obvious that people using the app recording things where they are should be there, but we were still quite happy to see that that the sampling looked like something we expected.
So after this qualitative analysis, we perform further quantitative analysis of the data, and we basically what we did is what we call kind of unit tests, but for biological trends. So basically, since Bylot is a long-term monitoring project, and we know the system has been studied since the 80s, there are trivial trends that are observed at Bylot every year since then. And we wanted to verify quantitatively if those trends were highlighted by the data collected through Mobile. We had some issues in the field where people reported losing some data during the synchronization process. So that quantitative verification was important because it would allow us to see if those holes in the data might led the analysis to conclude false conclusions about the trends that we see at Bylot. So we test a bunches of species, and just to show you a few examples here for the snowbunting, like Fred said, this bird prefers to use patches of lands where snow melts at a much later date. You can see the data that was recorded on Mobile here, and you can see here a raster map of the snow melt date after September 1st on the island, and you can see that the points are mostly concentrated towards area where the snow melt at a much later date, which was encouraging. And basically what we did is a simplified resource selection analysis where we compared mobile observation to pseudo-absence data. If you are interested in performing such tests to your system, you can reach out to us, and we will share code and details of this without any problem. But just to not dig into technical detail, basically we noticed that indeed the model, the analysis was able to highlight the fact that the mobile observation indeed were able to highlight the fact that snow buntings were selecting patches of land where snow was melting at a much later date, which was very encouraging. And we were able to confirm similar trends like that for a bunches of species, but there was also some specific cases where the observation might be a little more tricky to see that unfortunately didn't quite work as well. So like Fred said, the American golden plover really is not really found in the goose colony because this little guy is quite fragile, and there's a lot of predator in the area of the snow goose colony. So Arctic foxes will unfortunately kill this huge guy, so you won't find it in the goose colony. You will find it elsewhere. But unfortunately, due to the fact that some of the data in some regions of the island were lost, the model or the analysis wasn't quite able to capture the fact that golden plovers aren't found usually in high numbers in the goose colony, and there was quite a lot of noise, which indicates that as a take-home message, the whole majority of the trivial relationship can be highlighted from our preliminary analysis, which suggests that Mobile is probably a very good tool to replace, I would say, manual field collection in the field. But since we want to produce scientific knowledge out of these observations, bugs can sometimes lead to false conclusions, like the ones I just presented to you, which highlights really the need to have fail-safe data collection protocol in the case of using any kind of technology when producing scientific knowledge out of it. And from those results, maybe we will share some dreams that I can let Fred share.
Yeah. So the issue we encountered is that we had 2 or 3 months of data collection on our phone, but then we don't have internet. So then it means that if somebody loses their phone or if there's a synchronization problem, then there's 2 or 3 months of effort that could be lost. And so when we got out of the field, actually, I was so sad because my phone was a problem. But when we got out of the field, I had like over 1,500 pending reports on my phone. And upon synchronization, there was a problem. We don't really know what happened. The synchronization process didn't work, so the data disappeared. And so then we lost the data, and then we were like, oh, that's a bugger. But the good thing is that it was a test year, so like none of that data was crucial. We were able to we were still doing our older transect surveys and stuff. But moving forward, that like a dream of us, and we've been talking abundantly the entire conference to the EarthRanger mobile team, but a dream of us would be to have a feature to manually export the database in the field so that we can do backups and that there's no risk that the data would be lost upon leaving. And then a second dream of ours would be to have an offline base map, and I know that it's in the roadmap of Ranger Mobile already, but we use custom maps like that in the field, and so we have the location of all the nests that we found in previous years, and we have topographic maps and locations of transects, and so when you're in the field, you can see where there's some interesting things to inventory, and we will revisit every one of these sites. So if we could have an offline map, then we would be able to optimize our work by knowing where we are relative to these features. So these are like two dreams that we have regarding Earth Mobile, but we're really enthusiastic about what it allowed us, and really the amount of effort of sampling effort that was deployed without having people specifically working on these questions. People were working on many other things. There's a lot of other data that was collected, but we were able to sample the entire study area. And so as a way forward, we have a network of researchers across the circumpolar Arctic that are interested in Arctic fox and its relationship with prey species. There's 34 sites where we have tried to harmonize protocols since 2017 so that we can do circumpolar studies and understand better what are the general drivers of these interactions. And the tricky part is that to harmonize those protocols, for now we send a PDF that says what are the instructions, and so some people follow them, some people kind of know, and then we have to collect all the data and try to find a uniform way to have that all together. And so eventually, if we can have like really good confidence that it works in an offline remote setting like the Arctic with EarthRanger, we would definitely be really happy to reach out to them and then ask them to use the app. So you just say, oh, install that form, and then we all have this similar database. We can all collaborate and another way forward is that we would like to find ways to inject the data that we collect through EarthRanger into other apps that have been developed in the Arctic that are, there's like the Siku app, which is an app that was developed by indigenous communities, and it's the indigenous social network, they call it. And it's quite different purpose, so we didn't necessarily want to use that in the field because we don't have any control on the forms and on the how the data are sampled. But we would be really happy if our data could be seamlessly integrated to their platform eventually, so that we contribute as well to their monitoring effort. And yeah, and in the end, there's a picture of what the Catherine think that we are. So, so to the left are all the data protocols, and to the right, the hopeful future of technology. So we're happy to take questions if you have any.
Questions?
Thank you. One thing to consider is using a Bluetooth antenna, GPS antenna, so that takes away the reliance on the GPS on the phone. And we've used that successfully. So Garmin makes a device that you can connect to, and then it samples the GPS locations. Anyway.
Cool. Thank you.
Yeah, that's really cool. And do you know, I don't know if there would be somebody that would know about the cheapest, best phone to use EarthRanger with? Like, what model of phone would be an ideal phone that you can buy for workers? I don't know if because there's a trade-off into like, yes, if we buy iPhone for everybody, it's great, but then it's gonna cost so much money.
Definitely, I mean, the phones that we recommend in terms of the best quality in GPS accuracy and like not that expensive, we have recommended the option of phones from Google. So those ones have been working really well. But it totally depends on on the budget of the park. We have other couple of scenarios in which users use iPhones from previous versions that are not really expensive, but they need to have like a trade of not the best GPS accuracy. But as Jake mentioned, maybe we can start exploring other options that could potentially help even old phones to get better accuracy seen those kind of cases a lot. So it definitely helps us a lot to understand which kind of phones would help other users as well. But yeah, we need to continue making those kinds of analysis with different phones. But yeah.
More questions? I have a question. Is there anything that you can infer from the areas that are in between your sample areas? Because I know you said you were kind of in one spot and then you would take a helicopter to another, but is there anything you can maybe infer?
There are various kinds of analysis you can do in ecology related to this data. Some you suppose that the species wasn't seen, so we could have used that, but this leads you generally to highly biased estimates of the abundance of the species on the area. So a really nice thing about ER Mobile is that it really allows us to see the sampling effort of our colleagues, and by having the sampling effort, we can get better estimates of the abundance of the species in the area. But you can also use the whole area, but you can expect to get something statistically less.
From the data that we have in the areas that we have, we can understand the species, and then yes, we can interpret what we think would happen in those holes. But we really need to consider, as Catherine mentioned, this sampling effort, because then it would completely be biased by the area where we go or not, if we were to consider that everything was actually sampled. So I think that with the years to come, this year was still, not everybody in the field was using the app, and we were in certain areas, but definitely what we want to do is eventually target these places where we don't have information and go invest sampling effort there, and having this map of, okay, which areas did we sample, which areas did we not. Go fill these gaps. So we could say, okay, what did we sample so far this season? And oh, there's gaps here, here, and there. We'll make sure that we go and sample thoroughly these areas.
Because I think before we tried ER Mobile, there wasn't really a way in the field to know where people have been or.
Well, we had our systematic transects.
Okay, yeah.
Just a quick question on the sampling effort. You were filtering the track, but were you filtering based on patrol segments or based on speeds, and before that?
about like when the person started recording or walk to perform a census of species in the area wasn't available. So we had for now to do like filters based on speed, maximum distance, and also duplicates. Sometimes there were duplicates in the GPS tracks. I don't know if someone else in the ER mobile user community has mentioned that sometimes data can appear more than once. But those were filtered that are not perfect. But next year, indeed, we want to use the patrols to exactly know when and when it started and when it ended. But for now, this cleaning pipeline allowed us to get like an approximate idea of when the tracks began and when they ended.
Well, thanks.
You mentioned that you were planning on or already working with communities, and excuse my ignorance, has language been a massive barrier for you guys, or not necessarily?
In a way, yes and no. So most people in these communities speak English, so we can communicate in English. All of the documentation or all of the exchanges that we have are translated in Inuktitut, which is also the language that is you need to have translation through that. And so there are some field workers in our team that are from these areas as well, so that helps to communicate too. We would definitely like eventually to have a version in Inuktitut of the app, but at the moment we don't want to arrive and try to replace the app that is already there. So they have a really useful app, and it's more focused on sea ice condition. So one thing that is really important for them is that when they travel on the land, they know where the ice is reliable and where it is not. And so the app Siku means ice, and basically they sample the ice, and people can say, oh, I went in this area. And so there is some interest to have information about wildlife, but not that much interest into us trying to push our app into the communities. So what we want to do is mostly make sure that what we do can be useful for them by injecting the data and still keep some flexibility in our ability to have questions that are specifically informed by the conservation needs of the park or stuff like that. So.
Any more questions?
Great. So, well, thank you for attending, and don't hesitate to come and talk